in the city.
Alex Caputo-Pearl is with the Teachers Union. Today's bargaining session to be mediated by officials with the mayor's office. Rain in the forecast at least through the afternoon, beginning to clear up tomorrow and into the weekend. Jeff Scott, California News.
I never chose to become a gambling addict, but what I did choose was to get help from a professional counselor.
For no-cost gambling addiction counseling, call 1-800-GAMBLER or text SUPPORT to 53342. Brought to you by the California Department of Public Health.
A national title game that was a shock to many. It's this week's Geico Sports Now.
It's this week's Geico Sports Now.
The number 2 team from South Carolina played like they were the favorites and won the big game, going away 44-16. It's Alabama's worst loss in more than a decade. Clemson is now the national champs and takes home the giant trophy that goes with it, which weighs in at more than 30 pounds, by the way. Don't take saving money for granted. Go to geico.com and you could save as much as 15% on your auto insurance in as little as 15 minutes.
I never chose to become a gambling addict, but what I did choose was to get help from a professional counselor.
For no-cost gambling addiction counseling, call 1-800-GAMBLER or text SUPPORT to 53342. Brought to you by the California Department of Public Health.
NBC News Radio, I'm Angela Anderson. There will be no U.S. delegation at the World Economic Forum in Davos, Switzerland. President Trump canceled his delegation's trip because of the government shutdown that's now 27 days old. White House Press Secretary Sarah Sanders wrote in a statement, the president made the decision out of consideration for the 800,000 American workers who are not getting paid. The president also grounding a military plane that was scheduled to take the Speaker of the House to Afghanistan to meet with military leaders and troops. NBC's Kelly O'Donnell from the White House.
This is the president, in effect, pulling the trip in order to guarantee the presence of the Speaker of the House in Washington with the hope that they can continue to negotiate. If we saw a power move from the Speaker to pull the plug on the State of the Union for January 29th, here's the counterpunch that we've been waiting for.
It was just yesterday that Speaker Pelosi suggested the president postpone the State of the Union address. The Trump administration not giving up on its goal of asking people if they are citizens or not on the 2020 census form. The Department of Justice is appealing a federal judge's ruling that adding a question was unlawful. The case may ultimately be decided by the Supreme Court. At least 5 people dead because of storms pounding parts of California this week. Many residents in the Bay Area experiencing torrential rain, high winds, and coastal flooding. But NBC meteorologist Bill Caron says the entire state is affected.
We do have a couple flash flood warnings, and a couple flood warnings are out. We have blizzard warnings, wind advisories, high surf advisories, flash flood watches. It's a mess throughout much of California. Travel's difficult, to say the least.
And 2 skiers in the hospital after being buried by an avalanche near Taos, New Mexico. Local TV reports that 2 men were found unresponsive and not breathing, but first responders were able to revive them. Ski Patrol at Taos Ski Valley Resort conducted a search to ensure no one else was trapped beneath the snow. You're listening to the latest from NBC News Radio.
KCAA Radio is proud to announce that the Tri-City Center in Redlands is our new home. We're fortunate to be located among some of the best businesses in the region. Among our neighbors are Ray Chiropractic, Brace Connection Orthodontist, Pain Solutions Medical Massage, Rent-A-Center, MVP Staffing Agency, Jenny Craig, Salon Centric, and many more. The Tri-City Shopping Center is located just off the I-10 between Alabama and the Tennessee exits in Redlands. The Tri-City Center is the mall with the heart.
Express 106. 106.5 FM. KCAA. Southern California's best talk. NBCRadioNews.com.
Live from the NBC News Radio broadcasting studios of KCAA, 1050 AM, 102.3 FM, and 106.5 FM, located in beautiful, raining Southern California. Thanks for tuning in to the Water Zone Show. I'm here with our great co-host, Mr. Chris Davies.
How are you tonight, Robert?
I am doing great. I'm wet, but it's fine.
Splendid. I'm the same. I just tied up the kayak outside and came in and sat down.
Good. You still have your galoshes on.
Yes, I do.
But I got to say, that Speedo, that yellow Speedo.
Thank you very much. It's a little chilly out there.
It's a little chilly out there. So, hey, we got friends watching, so we'll give a
hello, everybody.
We'll give a wave to everybody. And today is a special day. It's our IA training show of the Irrigation Association. It's good for both professionals and also non-professionals who want to learn things about irrigation and have nowhere else to go but here, because you can't go to big box stores and learn this stuff. Do you ever go to big box stores and ask them for a valve?
No.
You don't want to do that. They don't know much about it. But anyway.
Right.
We'll take amateurs too, by the way, everybody. So if you want to listen in, amateurs are welcome.
Absolutely. It's a good thing. I know you have some announcement about a new show coming up.
Well, I was just going to announce the
industry trade show.
Right, the California Landscape Contractors Association, also known as CLCA. Just an announcement that in a couple of weeks here, coming up on February 6th and 7th, is the Landscape Industry Show at the Ontario Convention Center right here in Southern California. For those of you who are looking for a day or a few hours to go and learn about the irrigation industry and plants and chemicals and tree trimming and
chemicals,
everything you can. There's classes that are available, similar to earning CEU credits, like you will be able to tonight with this show.
Did you say chemicals?
I did.
Just kidding. How does it cost to go?
Right now, if you go book online and you go to their website, you can actually get a free show floor ticket.
Cool.
And those are available, I believe, until just 24 hours before the show starts.
Excellent. That's a good deal. Is it all in English, or do they do it in different languages?
They do it in English and they do it in Spanish as well.
Cool. Yep. That's a good thing. So anybody who really interested in that, I think that's a good deal to go to. This is where you get real irrigation information.
Absolutely.
From professionals, and I recommend that. So anyway, today is our training day, as we said, and we're going to feature a gentleman named Scott Kyle. He handles product for our company, and we have to disclose that. He works for the Toro company, but he works for the Rainmaster Group. And today's session we're going to talk about is central control systems. And, somebody might say, hey, what's a central control system? Well, it's not something that somebody puts in their normal house, but I'll let you explain that, what it's for. And for those that are listening or watching, almost towards the end of the show, I'm going to give you a code, and then you send an email to the Irrigation Association with the code that we give you, and you'll be eligible to get the continuing education units. So that's a good thing. It doesn't cost you anything, and you'll have a great conversation. We'll learn a lot. And so I'm going to introduce Mr. Scott Kyle. Scott, how are you?
I'm well, sir. Thank you. Thank you for having me.
You don't have to call me sir.
I'm excited to be here. I was honored to be invited, and I hope to take you on a little journey this evening. You may be familiar with the term 30,000 foot view. Mm-hmm. It's kind of a wide angle view. Tonight I hope to pull us down a little bit underneath the clouds and maybe do some treetop flying right around the 500 foot view, if you will. So intentionally not deep diving too deep, but going on a nice journey. I think that should be enjoyable.
Oh, I'm tightening my seatbelt right now.
Yes, yes, sir. Good thing is we'll be below the clouds.
All right, awesome. So we're ready to key it up. For those of you watching on the screen, you can see the presentation right along with us.
Oh, yeah.
Yeah, might as well let everybody know.
Go to KCAARadio.com, and you can watch us live. That's a good way, or Tiki Live. And if you want to call in, if you have any questions, you can do that at 888-909-1050 or 909-792-5222. And at the end of the show, we'll also give you an email address if you have some questions that you didn't get a chance to get in, and you can send it to us, and then we'll forward it to Scott, and he will answer that very, very quickly back to you, and we'll be glad to help you out on that. This is pretty interesting because most people, they don't understand what this means as far as non-professionals. But if you live in an HOA or, you have a condominium complex or things, they probably have a central control system in a larger price. But I'm going to let you, I'll play stupid. I'll just act natural, I guess. So, no comment. Good. You can stay for the show. So anyway, what is a central control system?
Well, I think you'll see as we go on our journey here, As a general term, I like to look at central control systems as a way to control your system from offsite or remotely. And I think that we'll all agree that we've come a very long way through our journey of control systems and irrigation controllers themselves. And the sky's the limit. We don't know where we're going to end up or where we're going, but here we have a satellite, right? So it's collecting data over the Earth. And this next slide is going to explain to us that early irrigation systems were designed by engineers. And they were offering underground sprinklers. That was a special thing at the day. It says here the first automatic sprinkler system was patented in 1872. Here's a gentleman by the name of John Brooks, a picture of his office front there. He was an irrigation engineer offering underground sprinklers. And, these systems were, for large budget and the elite. These installations were found across the world, typically of very wealthy clients, kings, titans of industry. Many of these installations could be found around the world, and including the Capitol in Washington, D.C.
Do you know where that picture was taken, Scott? Was that in California? With the
I do not recall where that picture was taken, but obviously that he was an irrigation engineer, and on the front of his office it was a specialty for underground sprinklers. Irrigation controllers have also come a long way. So for those of you that can view this show, we have a snapshot here of some old irrigation controllers. Some of them I can tell you what they are and what they did, and there's might be one or two in there that are even before my time. But most of them were, back in the day, hydraulic, electromechanical, very inefficient and difficult to program and use.
Big dials.
Yeah. Early central control systems, we started moving into a computer environment managed on binary computer systems, very large, difficult to manage.
Looks like a Sperry Univac computer.
Yeah, it's an oldie for sure.
Punch cards?
I think that was managing a golf course. I couldn't tell you which one, but it managed a golf course.
Do you have a circa date for that photograph right there?
Unfortunately, I don't at the moment.
Judging by the haircut and the clothes?
I probably do in my notes in preparation for this, but I didn't commit that to memory.
Looks like the 70s.
Now, here's another great one for you. Bulky, expensive mainframe computers. So we've come a long way. As technologies advanced, so did our irrigation controls. We moved to a solid state controller right around 1976. Here's a prototype from that era. And, these early prototypes truly helped shape advanced management systems. Here's another early controller. As controllers and technologies advanced, we moved into wireless communication networks, weather-based scheduling with flow sensing, and there's, of course, one of my favorites, and remote alerts and notifications, as well as maintenance remotes. So all those became tools that advanced over time as new technologies became available. As we advanced in the central control system, so did the software. Central controls evolved to be in PCs. For government facilities, school districts, cities, PCs moved into offices and didn't look bulky and expensive and like those other pictures we saw. They were for sports fields, master plan communities, and they became more widespread and readily available and more cost-effective to become used throughout. Advances in the controllers themselves provided efficient water management tools that actually had a calculable ROI with daily schedule adjustments utilizing ET, reduced labor costs with improved productivity, flow protection and automatic system shutdown, automatic remote shutdown for rain, freeze, and wind, with accurate record keeping. These new systems provided modern graphic interfaces which provided very powerful and total site management tools.
I'm familiar with that part of town on that map right there.
You recognize that map? Where was that from?
That's Newport Harbor, yes,
It is
and
Newport
Back Bay,
Beach.
and the.
It's one of my very close customer to my heart in the city of Newport Beach.
Yep.
So when this was started in the central control systems, what was the largest size? How many valves could they operate then versus what you see today?
Well, that first picture that we saw there was a golf course, right? So that was probably a typical system back in the day. Now, we have systems that have from 1 or 2 controllers ranging to hundreds and hundreds of controllers.
And how many valves would they operate?
Well, as we move forward here, you'll see that advanced control systems can typically range between 8 to 200 zones or stations. Yeah, but as we had moved forward and what provided an actual ROI for these systems to become widespread was ET-based scheduling or weather-based scheduling. So when we talk about ET, we talk about evapotranspiration, right? The evaporation and transpiration. The sum of transpiration plus evaporation from the land surface is how we calculate ET, and it's measured in a period of time, typically in inches over a period of time. For those of us that are involved in daily schedule adjustments, we're looking at that ET value on a daily basis.
So evaporation is the loss of water off of the surface, right? And transpiration is the loss of moisture through the plant.
Through the plant material,
yeah, right.
Yeah, so it's the water that the plant used and or transpired from the plant material.
Right.
Yep. So now that we have an idea of what ET is a little bit, we're going to talk about where do we get that data. So the typical ET sources include, I have some pictures there for those of us that can see the slide, but they include on-site weather stations, and there's a variety of weather stations that provide that data to us, as well as on-controller weather sensors, and internet or web weather, which is what we commonly typically use these days. So we kind of know a little bit about what ET is, where we get it from, and I want to explain a little bit of how we use it in our scheduling practices, if you will. And one of the interesting notes on the slide is from the EPA's website, and it says experts estimate that as much as 50% of irrigation water is wasted due to overwatering caused by inefficiencies in irrigation systems and methods. So in our world, what we try to do is utilize this ET information and adapt that into our scheduling models. So plant water needs change on a daily basis, and as you can see in the graph there on the far left, that's representing January. In the middle, around the 177, is our July range, and then towards the right-hand side is December. Mm-hmm. So you can see a bell graph there of what what it looks like throughout the year. And as an example, if you see on the left side of the slide where it says 0.25, that would indicate about 1/4 of an inch of ET, right? So it's not a lot, but that's what that represents.
Per day.
Per day, yes sir.
Right.
So that same graph here put up, we talk about how do we get that data and what do we do with it, and how do our schedules get changed? We were in the old days lucky to maybe do some seasonal adjustments, 2 or 3 adjustments throughout the year from the maintenance personnel to try to get some seasonal budget adjustments. In this slide, we talk about or we show basically monthly adjustments. So monthly is certainly better than seasonal. However, everything below the horizontal line in the blue is still wasted water. It's still where we could have area for improvement in our scheduling practices. So monthly adjustments are better than seasonal, but it's really not where we are. It's not our goal. It's not what we're trying to get at. What we really want to do is have these daily ET program adjustments match the ET. So in this example, you see the irrigation schedule perfectly aligning with the ET values throughout the year. And that's truly the goal.
Right. Now also, you made a mention of the description of what the ET is. But, I look at it like the ET information is the engine of a big race car.
Mm-hmm.
And the irrigation system, if you have 10 pounds of pressure in your tires, you're not going to get your mileage that you think you're going to get. So that's only half the battle, is having the right irrigation schedule and equipment, but also the irrigation components out in the field. That's got to be up to par as well.
The distribution system has a lot to play into that equation. As you remember, the EPA slide talked about inefficiencies in systems and scheduling.
Right.
So they definitely work hand in hand.
Exactly.
So now that we know basically what ET is, what the sources are for it, and what our goal is with it, I'm going to give you a basic overview of how we integrate that into our irrigation schedules, if you will. So in this example, a manager defines a zip code location of this system or their controllers within that system, and a reference ET value. So the reference ET value is typically the warm season daily average, if you will. So the warmest month, the daily average of that. To keep it kind of simple, ET below our reference is going to reduce our run times, and ET above our reference is going to increase our run times, if that makes sense to you guys. You with me so far?
Yep.
Thank you. So now we're going to look at how that plays into our daily programming adjustments. So in this case, a manager defines a peak season program by defining a start time, in this case 2 start times, the station run times, the water days for the schedule, and then the system automatically adjusts using ET, the ET percentage, which automatically adjusts the run times. So if you follow me there, we're at 50% of our adjustment, which means our ET that was delivered was half of our reference value. With me? So you can see we have an 8-minute run time, and it's been reduced to 4 minutes.
And just to make sure, excuse me, just to make sure of those who are just listening, you can actually see the slide presentation at KCAARadio.com, and it's live, so it's easier to follow and probably more understanding. Always have to say that because some people just listen, and it's helpful to see the graphs.
Absolutely, it's a very detailed presentation, and it'd be very helpful to visualize what we're talking about. In this scenario, we're going to show daily ET, but we're going to kick it up a little bit and maybe become even a little bit more effective by introducing a cycle and soak feature to our programming. So we already know that the system automatically adjusts the ET, right? We saw that a moment ago. And we know that the system automatically adjusts the station runtime. In this scenario, the manager is going to define a single start time rather than 2 start times in our last example, and the manager is going to define a maximum cycle time. So in this scenario, I think we're much more effective. Theoretically, in the last scenario, the manager reduced the run times for each zone by 50% and provided 2 start times in order to reduce runoff and attempt of being more effective at putting the water in the root zone. In this scenario, we give it 1 start time, yet we can fine-tune each specific zone to a maximum runtime. So our goal here is to reduce the runoff, as well as if we have very porous soils, that longer runtime may go beyond the root zone depth into an area of the soil where the plant can absorb it. So in this scenario, we can provide for a maximum cycle time as well as a soak time if it needs it.
So just for the listeners that may not be familiar with the term cycle and soak, can you do a little 1-minute definition of what that purpose is?
Yeah, absolutely. So with the maximum cycle time, that's basically the number of minutes you can irrigate before runoff occurs or ponding.
Or the saturation point.
Or the percolation of the soil is such that the water goes below the root zone depth and the plants can absorb it. So rather than just arbitrarily cutting the run times by 50% and having 2 start times, with this methodology, I can define exactly for each zone when that runoff occurs or when the ponding occurs, perhaps due to overcompaction of the soil, or for the very porous soil, that deep percolation may be taking place beyond the root zone depth. Right? So rather than system-wide cutting things in half and hoping that that does what I need it to do, here I can define it by zone. So I hope that helped answer your question.
It did. Thanks.
Good. In this next slide, our adventure is gonna take us into daily ET using some advanced features. And in this scenario, the manager is going to define some scheduling constraints. In other words, a water window and perhaps an irrigation season. Here in Southern California, we're kind of open season all year long, but not necessarily across the nation. The manager could also define allowable water days. In other words, days that the system can come on, as well as the maximum number of stations or programs that can run simultaneously, as well as available programs and stations that we want the system to be able to use.
Now, in case of a water window, say the city water agency says you can only water between 10 o'clock at night and 6 o'clock in the morning, and say you're doing a college campus, let's take a huge place, and you have X amount of valves to run. But if you look at the time allotted and your ET value, you may not have enough time to run through the whole system. Can you run on most of these controllers? Can you run, I know the answer, but I want you to say it, can you run multiple valves at the same time?
Absolutely. So based on the electrical constraint available from the controller, we can irrigate multiple programs at the same time. And as our journey progresses here, I'm going to show you how the controller can intelligently define which stations can be turned on simultaneously. But in this scenario, we're kind of looking at daily ET with some advanced scheduling, if you will.
So we're going through some scenarios where each slide you're just
building,
introducing and more definition
absolutely
into what we can do.
Absolutely. I told you it's going to be a nice friendly journey. At about 500 feet, treetop flying.
Did you bring any snacks?
We may need some nuts before this is over.
We got 3 nuts sitting here.
3 nuts right here.
We may have plenty then. So those are what we call scheduling constraints. In this next build upon slide, if you will, the manager is going to define what we call station attributes. So for each station, and I look at the station attributes like water audit data, if you will. So we're going to define some bullet points to each station, such as microclimate, soil type, precipitation rates, maximum depletion or maximum allowable depletion, station adjustment percentages, root zone depths, slope factors, and station efficiency or distribution uniformity. And the end user or the manager also has the ability to define the plant material and its crop coefficients for each month throughout the year. So in that scenario, the schedule would be built through using that engine and that criteria to define and maximize the schedule for us utilizing daily ET. Now, a moment ago, you touched, Rob, on, you were segueing me into how do we work with systems that are large. We have a large number of stations. You had a short water window to get them done. So quite often on those larger campuses or large facilities or facilities where the general population is going to be there early in the morning, maybe a PE field, public area, we want to irrigate as many stations as we possibly can. And when you hear that, the general term is called flow managers. I like to refer it to as advanced irrigation management. So as you know, we love acronyms, and we call that AIM. So a flow manager, when you hear that, it's really what it means is it's the optimization of the water source, if you will. So this next little journey we're going to go on is going to talk about how that works, and we might go a little steeper on our altitude here for a minute, but I'm gonna take care of you, and we'll be all right.
You know, there are some areas, let's say it in where the snow is, Yeah, and it's like 38 to 40 degrees in the morning, and it doesn't warm up to like 50 or 60 till 10 or 11.
Yep.
So what do? If you have the smart irrigation system, and you can set your limits at what temperature you want this thing to happen, that's going to be an important factor too, because then you shouldn't water when it's almost freezing out.
I agree. Yep, that could be another very important factor.
Right. And those are all figured out in these as well. You can program all of that.
A lot of our customers in areas where we have weather of that nature have freeze sensors.
Right.
Rain and freeze sensors, and so they're monitoring that. Here in Southern California, not so much. We irrigate almost all year. We might get a month or two off here and there. But in this scenario, we're going to talk about flow managers. In other words, we're optimizing this water source that we have. And in this scenario, the optimization minimizes your cycle time. So in other words, we're completing our irrigation earlier than we would have. We're maintaining our flow and our pressure throughout the irrigation event, as well as potentially reducing water hammer in our system and maximizing the efficiency of our pump, should we have one. So the overall effect is we're going to reduce our runtime and maximize our cycle. So we're going to build upon this, and you'll see what I mean. In this scenario, we have I'll call it lineal scheduling, if you will, scheduling in sequence, stations 1 through 8, very simple, 8 stations, 10 minutes each, right? 80-minute total runtime. Make sense?
Yep.
Just boom, 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 10 minutes each, stations 1 through 8 sequentially. What we want to do here is we're going to optimize this water source. We can see at the top of the slide that we have 100 gallons as our source, so 100 GPM limit. And what the system says is instead of starting with stations 1 and 2, it realizes that station 3 is 100 gallons a minute, so it would go ahead and irrigate that station first. The next thing it intelligently realizes is that stations 5 and 6 total 100 gallons a minute, so it would irrigate those two next. And stations 7 and 8 also total 100 gallons a minute, so they would be in the next group. And then it says I can finish off with stations 1, 2, and 4. They only total 90, but I can group those 3 together and not exceed my source. Make sense? So when we've maximized or optimized this water source, we've reduced the cycle runtime, we've put the stations into 4 groups like Rob mentioned, and they've still ran their same number of minutes. They've still put down the same amount of water. We've just got the work done in half the time. So we've improved our efficiency. In this next scenario, we're gonna optimize the same water source, only we're gonna say that about halfway down our main line, we have 2 sources. So 100 gallons a minute at the top of our source, yet perhaps there's a pipe reduction. Maybe we have a smaller size main line halfway down the line, and maybe it can provide us with 80 gallons a minute. So now the system is going to maximize our program without going over what the systems or the sources can provide, without exceeding them. So we know it likes that station 3 because it maximizes the first source or the primary source. The next 2, it says I can grab station 2 up in this primary source, and I can grab station 5. They total 100 gallons a minute. So now I can irrigate those 2 together without exceeding either of my 2 sources. And the next 2 it would grab is stations 4 and 8. And they total 100, but combined together they did not exceed the 2 water sources. So it would irrigate those 2 next. And to finish off the sequence, it would grab stations 1, 6, and 7, totaling 90 gallons a minute. Again, not exceeding either of the 2 water sources, putting them into multiple groups, 10 minutes each, with a 40-minute runtime. So again, we've maximized the 2 sources without exceeding the supply of either. Make sense? Any questions? You good to go? Okay, so an interesting, question that may come up with this topic is that, well, Scott, we don't irrigate 10 minutes on every zone. That's kind of ridiculous. Every station has a different number of runtime. The systems are intelligently managing that, and as soon as a station runs out or exceeds or finishes its runtime, system intelligently grabs the next best valve and puts that in its place. As the next valve finishes, it's constantly relieving valves from their runtime and putting in new stations to maximize that source.
And you can also set, once the valve is turned off, you can set the time before the next one starts, so you don't automatically run a second group with this. Is that correct?
Absolutely. It's very customizable. Right. So in this scenario, I didn't want to get too over the top, if you will. Yeah. But I did want to explain that
we're only at 500 foot level.
We're at about 500 feet. We might be dipping a little lower at the moment. But to couple back to your comment in regards to how do we finish our irrigation on large sites, we want to irrigate multiple programs at the same time. Right. So that's really what these flow managers do. And when you hear that term, flow manager, this is really what it means.
Right.
It's optimizing our water source.
And for anybody listening that does have a question in between, you can call us at 888-909-1050 or 909-792-5222.
So our next journey, if you will, is going to bring us into flow sensing. And I think it's an extremely valuable tool. And surprisingly, it's typically a fraction of the cost of the total irrigation system. So when we discuss flow protection, we talk about protecting main lines and pumps, shutting down in the event of catastrophic event. Obviously, this is on the slide. If you're here with us visually, you can see a huge slope failure, and at the top of that picture, there's a distribution line that's broken and created a large slope failure. So that's one of the things that could have been protected with a very inexpensive flow sensing feature. Lateral lines, of course, it's more day to day. But in either case, I tell people that are the best schedulers, you can have the best scheduling, you can use advanced ET, you can use flow managers. But if you have one mainline break that goes undetected, literally you could have lost your entire year's worth of savings and hard work down the drain, not to mention the cost of repair that it associated with, breaks. So I look at flow protection as well as a protection of our savings, right? It's like an insurance policy as well. So when we talk about flow sensors, there's a large variety of flow sensors that do different things. There's a lot of types. Some of the most commonly used are here displayed on our screen. They range in connection sizes. They range in flow ranges, if you will, and they also range in pressures that they can accommodate. So, the reason that these items are important is that there's very common disconnect in that if somebody has a 2-inch main line, they think they need a 2-inch flow sensor, and that's simply not always the case. It may be the case, but quite often you have to look at these charts in order to determine the correct sensor for the system that you have. And maybe one sensor doesn't incorporate your entire system. You may have part of your system might be drip or low flow. Some of your system might be a higher flow. You might need more than one flow sensor. So in this next journey we're going to go on here, I'm going to talk about how we would typically set up multiple flow sensors on a site. So in this scenario, the end user, the manager, defines the sensor types that he has. So here we're going to use a 2-inch sensor and a 1-inch sensor to accommodate our flow range and our pressure of the system. Here we can set the mainline limits, the unscheduled flow limits, as well as set a pipe fill time, or what some people call a flow check delay. So that's kind of the behind-the-scenes setup, if you will, for the flow sensing feature. As we progress, we want to know how to set up individual stations. So most systems have an auto learn feature. So when I say that, the system itself or the controller will turn on each zone for a couple of minutes and memorize or learn that GPM value for that station. And it will do that throughout the entire system. And it learns them in gallons per minute values, if you will. So we call those values, those gallons per minute, nominal flows. So each station has its own nominal flow. And you can kind of visualize it here. And the high on the flow limits for each zone are basically set as a percentage of the nominal. So the end user can set a percentage for high and low flow for each specific zone. Make sense? Mm-hmm. With me? All right. So here's something that I think is, as we're cruising through our journey here a little bit, and as you can see, we're moving into more modern times, and we're all familiar with what we're about to talk about here. But I think a very unique distinction that is worth mentioning is that Rainmaster introduced the first Internet Central Control System on June 9th, 2003. And you might wonder, why that's such a specific date. And to me, it's a special date because I was on the team that helped introduce this at Rainmaster. And I think it's anytime you were successfully launched the first of something on the world, it's a value worth mentioning.
That's right.
And I think it's an exclamation point in all of our careers that were there at the time. And Jim Szyminski was our leader back in the day. John Tarosian was part of the team. Greg Fast was part of the team. Bill Smiley was there. Carol Wood was there. And a few other people behind the scenes as well. But all of us were there, and we all participated in the development and release of a successful world's first internet system. So it's something I'm proud of, and proud to carry on the heritage here. We called it iCentral, and we still do. As we introduced this internet control, it allowed the connection to your system using a smart device. So no more cell phones, tablets, cloud connection, managed from the field, right? Which was a great advantage, and still is. No PCs or software that you had to report to. It was very easy to use, and it was reliable and very high powered. So Rainmaster revolutionized that central control, right? We took us out of the PC world and we moved into an internet world, and we all love to report to our phones rather than our offices. So that portion of that internet control, provided a very powerful management tool for folks in the field.
So since the conception of this, how many companies today are doing central control systems? Just to be fair to everybody else.
Less than those that tried, for sure.
Yeah, good point.
Off the top of my head, I don't know the exact answer, but there's probably 3 or 4 that are notable within our industry. But certainly many have tried and some have failed.
Okay.
That internet control, it provided the ability for folks to now work in the field and become more productive. Schedule adjustments now from the field on the fly, cell phone, tablet, manage system alerts, receive alerts via text, email, global remote shutdown, and easy multi-site management. So what we did is we took all those features that we talked about. We took ET, advanced scheduling, we took Flow Manager and AIM, and we brought that all to the cloud, and we made it able and easy and able to use out in the field. Right, so we didn't have to report back to a computer at the end of the day and do all of our scheduling adjustments or drive to every single controller and try to manage those. Now we're right from the phone, right from the cloud.
So smart connected devices and wireless networks and smart controllers will help drive sustainability into the future.
Absolutely.
And I see more of that coming, and I even see, they call it a client terminal. I call it a dumb controller. But eventually, you should be able to, or if you can think of it, it can happen. You can take the smarts out of the controller, meaning the microprocessor and all the RAM and ROM, and put that to the IoT or cloud, and have that do all the stuff, and just sends the water scheduling information to a, again, client terminal or dumb terminal, and it just runs the valve. Therefore, you can really reduce the cost of the product as well.
Potentially so. Yep. So we started out saying the sky is the limit. So we'll see.
Right.
We'll see where things go. We still have to keep things easy and manageable, and for the on-site person, right? And I think if we take things out of their hands too much, then it becomes maybe some blinders, and it's not really my responsibility. It's coming from some other place. So I think it's important to keep them involved and keep their interest in the game as well.
Mm-hmm.
So we'll see.
We're still at 500 feet here, right?
We're still around 500. Yeah. You
All right.
okay? You don't need an oxygen mask or anything?
Nope. So
All right.
next we're going to go and look how
He needs oxygen, but
you need some oxygen.
how technicians and managers in the field can know how well their system is working, and more particularly when it's not.
Exactly.
Yep.
So we talked about receiving alerts now from the field or from our cloud on our mobile devices. So with that internet control that we introduced, we offer flow sensing alerts, mainline and station alerts. In other words, if there's a broken mainline, the controller takes corrective action, shutting that down, the master valve, and then sending me a message immediately of what it did.
if you have a shorted valve.
Absolutely. Station wiring faults.
There you go. And I didn't see your presentation.
You're segueing me just
Sorry,
perfectly.
I didn't
I
see it.
appreciate that. Thank you.
Right.
Rain and freeze shutdowns, controllers out of sync, and of course administrative messages. So now we have a way of immediately communicating to every user out in the field right through the website instantaneously down to their device. So remote access to information became available, and I think this is another huge feature of what we provided with the internet control systems. We provided instant in-field access to information, communication information, irrigation schedules. A huge one is water usage reports. With the integration of flow sensing and internet control, we immediately have information at our fingertips, controller alerts, reports, daily ET information, it's all there.
And that's not only for the user, it's also for the companies who manufacture this type of equipment. They can actually get online and see what the user is doing as well.
Absolutely.
So that makes it really nice for customer support for everybody.
Yep. So as we move forward through our journey here, controllers and systems are advancing with technology, and certainly controllers advanced as well. To couple back into your question earlier, advanced controllers typically range between 8 and 200 stations, conventional, 2-wire, and hybrid. So hybrid meaning they can provide for conventional and 2-wire irrigation in one controller, full feature cloud control, advanced ET scheduling, multiple sensors and master valves, as well as AIM flow management. In regards to 2-wire, I'd like to touch on that just briefly if we could. Typically larger station projects, larger station quantity projects, if you will. There's a 2-wire path with decoders. Along that path, multiple path configurations. The one showed here is just a loop, what we call a loop configuration. Multiple station decoders along that loop connected to the solenoid valves. Lightning arresters along the 2-wire path, and typically the decoders can be programmed at the controller itself to make it easier for the end user or the installation contractor. One of the other great things that 2-wire controllers can actually are very good for is a phased project. So as we can see, we might have a very simple 2-wire path here, and we move forward into our next phase of our project. It's very easy to add on to our 2-wire path and add multiple controllers, add more stations.
Easily scalable.
Easily scalable. It's great for phased work. as well as retrofitting older properties that have aging, faulty wire systems. It's very easy just to run a piece of new 2-wire right down the mainline path, connect into the existing valves, and modernize your system. So these decoders are used typically for master valves, station valves, pumps. Here we depict a 1-station decoder, 2-station decoder, and a 4-station decoder. One of the things that I think, so now we're gonna go from our 500-foot elevation, if you don't mind, and we're gonna go subterranean. So we're gonna dip down again. That's right. So hold on. We're gonna go below grade.
The water droplets were coming.
Yep. we're gonna dip below grade for just a minute, and I think this is an important feature because grounding is very, very important to our advanced controllers these days, and it's quite often overlooked, in my opinion. And one of the primary questions when we're talking about grounding is where do we place the ground? How do we know where to put it? So we talk about the sphere of influence when we talk about grounding. And what that means is the sphere of influence is the area required to dissipate the energy. So in the graphic provided here, we have a 10-foot ground rod as an example, and we're saying that the sphere of influence is 10 feet. So a quick rule of thumb is if you have a 10-foot rod, your sphere of influence is 10 feet. If you had an 8-foot ground rod, your sphere of influence would be 8 feet. Pretty simple stuff. So in this scenario, 10-foot rod, we install it 10 feet from the controller. Install the ground rod outside the sphere of influence. So many controllers, especially here in Southern California, forever the ground rod is installed in the concrete base of the enclosure. Right, and what we're asking people to do is install the ground rod outside the sphere of influence so it has a place, a safe area to dissipate the energy without affecting the components within the control box. So making a solid connection is the next important thing to providing the proper ground, not only getting it out of the sphere of influence, but making a nice and tight connection at the rod itself.
Can you wrap that with the silicone tape to prevent any moisture because you're going to get corrosion from copper and things of that sort? I mean, I do that for my ham radio equipment. I put on all my antennas. I have this wrapping material.
It's probably a good idea, but I don't see that it is. I don't see that mentioned in any of the articles or documentation that I researched. Mm-hmm. Okay, so I'm not necessarily sure if it's might be a little overkill, but certainly couldn't hurt in some areas. Here in Southern California, we don't have a lot of lightning. No. But if you get into a lightning-prone area, I think overkill is not a bad idea.
Yep.
Okay.
And protects against moisture, too, as well.
Yeah, absolutely. Well, in the ground rod itself, or the ground plate, we want it to be in a wet area. So depending on the site conditions, you may not be able to pound a 10-foot rod into the soil, right? There might be a rock down there. So in this case, we have an 8-foot ground rod, and it's completely driven into the earth, and it's installed perfectly vertically. In option 2, it shows some rocky soil. We couldn't get it all the way in, so they've installed it at a 45-degree angle in order to get the entire ground rod buried in earth. The third option there shows the same ground rod, however, it's placed horizontally, and it's about 3 feet deep. So it's buried. You have the same amount of copper in connection with earth, and that's really what we're looking for, is that amount of copper touching earth in order to dissipate the energy. And what we never want to see happen is to have somebody cut the ground rod down because they hit an obstacle. Right? If you hit an obstacle, if you can't get the ground rod out, try again. You have to find a better way to do it.
Right.
So depending on the site conditions, right, a ground plate may work best. So in this case, we have a horizontal ground plate, and it's typically buried horizontally 3 feet deep. So in this case, it shows our sphere of influence, and that way you're not trying to maybe pound this thing 8 feet or 10 feet down into the ground. If you don't know what's in the ground, you might be a little worried about utility lines. certainly a ground plate could be a better solution for you.
It depends on the neighborhood you put this in. You may find some bodies, like in Chicago.
It very well could depend.
Find Louis.
So in review, here's a top view detail. It shows that the sphere of influence, there's a 10-foot rod there, and that the sphere of influence is 10 feet. So the rod is placed 10 feet away from the control box. The detail on the top is a ground plate. It's a 4-foot plate. It's an 8-foot plate. So that 8-foot plate is 8 feet away from the controller. And here's a side view detail of that same scenario. So I always will mention to an installation contractor or firm, refer to the manufacturer spec, not only the controller, but also the ground equipment that you're using, because they may have some tricks or tips for you, but you certainly don't want to void the warranty of your controller by not grounding it correctly.
Very important.
Yep.
Absolutely. And I think it's very overlooked, so that's why I wanted to spend 3 minutes or so here on this. So, one of the things that typically doesn't take place or rarely does is, or maybe missed, is the testing of the grounding during installation or after installation to make sure that it's even grounded correctly. So it's very simple to use and do. Set a clamp meter to ohms, put that clamp around the rod or the wire itself, and what we're looking for is 10 ohms of resistance or less. Okay, now that can vary, but what we say in our documentation is we're looking for 10 ohms of resistance or less. The lower the reading, the better. So when we started our journey a few moments ago, we talked about how central control systems have come a long way, and that there really is no limit. You mentioned it, Rob. On the top there, we see a thing called geospatial data processing. Now that's actually the Google Earth Engine satellite floating above us and constantly taking images. And you can go on that website and sign up for free and actually get the data. You can create your own maps. ET is one of the maps that they have there, but they have all different types of maps that you can customize utilizing their 40 plus years or so of data. So there truly is no limit, and we really don't know what or where the next world's first is going to come from, right? It's out there somewhere. We don't necessarily know where, but it may not be on this world, right? That could be the world's next there.
Mars.
It very well could be. So in conclusion, I'd love to say thank you very, very much.
Well, thank you. How do they get hold of you? Or should they just go to waterzone@toro.com would probably be the best way to go?
Yeah, if for any follow-up, I think the WaterZone website or email would be the best. And I think that, I don't know if it's possible, but I think if I could view those and maybe provide a global answer that can be put on the website so everybody can see the questions and the responses.
Absolutely. And for those who watched or listen, I got to give you the code so you can get your CEUs.
That's right.
It's very important. So what you do is you send an email to the Irrigation Association and you use this code WZZCC. So that's Whiskey Zulu Charlie Charlie. And just send that way they know that you listened in or watched in, and then you'll get your CEUs for that. I mean, we could go on for hours because there's so much. I mean, you did really a 50,000 foot more than the 30,000, but you did get down a little bit lower. And I think it was good for a lot of people who really didn't understand what the power of this thing can do, and it is for bigger systems. So.
Yeah, maybe next time we can have you on, you can share a little bit about the successes that the technology has provided in water savings and how people have.
It would be my pleasure. I think smart marketing left some room for a sequel.
Awesome,
great.
Very good.
So the one thing we have to tell everybody that's most important that you got to do, except for, well, including staying dry because it's going to be wet. Most important thing is to think blue. Good night, everybody. We'll see you next week. You have a great week and stay dry if you can.
Take care, everyone.
Good night.
Thank you.
KCAA Loma Linda, 1050 AM, 106.5 FM, and now 102.3 FM.